Target 49, solve for x absolute value inequalities. In order to do these, you have to understand how to solve absolute value equations, where we split it into two and solve for the positive and negative version, and you have to understand inequalities. One of the things you need to understand about inequalities is the symbol writing. The symbols are less than, greater than. Those get graphed with an open circle. Less than or greater than or equal to, less than or equal to, greater than or equal to, have shaded in. They take more lead to write them, therefore you have to color them in. It's kind of a matching concept that way. Now the way I remember them, if I'm going to write the word less, it has the letter L in it. This one looks like a letter L, and that's automatically less. So this is less than or equal to. This one then obviously is our greater than. So we have less than and greater than. And then we have less than or equal to, greater than or equal to, open and closed circles when we shade them. Now, getting into the details of what this is going to look like is that you're going to have to take these and split them into two because they are absolute value inequalities. So I'm going to take this x minus 4 is less than 9. I'm going to split it into two. I'm going to take x minus 4 is less than 9 and x minus 4 is greater than negative 9. It's kind of like that whole idea. When you have negatives, you need to flip the symbol. That is what you need to remember. Negatives, when you make this from positive and you switch it to negative, when you switch the sign, you have to switch the symbol. Okay? That is key. We're making switches there. All right? So when you switch the sign on the value of the number, you have to switch the symbol. Therefore, you can go through and solve this. Add 4 to both sides, and I get x is less than 13. On this one, when I add 4 to both sides, I get x is greater than negative 5. Then I have to go down here to my graph, and then go down here to my number line, and I say, okay, greater than negative 5. Well, remember, greater than or less than symbols are open circles. So I put an open circle at negative 5, put an open circle at 13, and then this one is pointing which way it shades from the negative 5. Point this way, greater than negative 5. All the numbers greater than negative 5 are over here. All the numbers less than 13 are back over here. So this is the area that gets shaded in between, and that's what it looks like. Now, that's what the graph looks like, and then we use that to get our final answer in domain notation, domain and range notation. So this thing starts at negative 5, which is less than all the x values, which are less than 13. So this is a trapped-in statement showing us that we have this much numbers that work, and then these open circles determine that we keep those symbols just like that. Now, this is called an AND inequality. It's called an AND inequality when they run together. It's this and this running into each other. Now, there is a trick to remembering that. If your question is less than, it's kind of like less than. It's less than and. They're going to run into each other. Now, what's interesting is this one's greater than, great or. This is going to be an or inequality where the graphs actually split apart. So these graphs run into each other and it looks like this with an and. This is going to be an or because it's great or than. So here we go. We're going to follow the same steps. We're going to do the 1/2 x minus 45 is greater than 80. And then we're going to change this. We're going to switch the symbol, so we have to switch the sign. So then that gives us 1/2 x minus 45 is less than or equal to negative 80. Okay, so we have to pay attention to that. Now we need to solve both of these. I'm going to add 45 to both sides, so that gives me 1/2 x is greater than 125. I'm going to multiply both sides by 2 because I'm doing 1/2. Multiply by 2 cancels a half, and x is greater than 250. That's one of my solutions. My other one is add 45 to both sides. I'd have 1/2 x is less than or equal to, when I take negative 80 plus 45, I get negative 35. Multiply by 2 on both sides, and x is less than or equal to negative 70. Now watch. It's less than or equal to, less than or equal to, greater than or equal to. That's a closed dot. So I put a closed dot here and a closed dot there. This would be 250. This would be negative 70. And then this one is greater than or equal to 250. So I'm going to shade greater than or equal to 250. So I'm shading over there. This one I'm less than or equal to negative 70. So I'm less than. So it's telling me which way to it's pointing which direction to shade, and I do that. Now this is a split graph compared to this. These two ran into each other. Now what you need to notice is this is called an OR inequality, because this is showing me that x is less than or equal to 70, those are all the values that work, or x is greater than or equal to 250. Now I told you that little trick before that this is going to be an OR because it has great or, greater than, or, split. This is going to be less than, and run into each other, and your answers are going to look like that. So those are the major concepts that you need to understand for inequality, absolute value inequalities. You still split it into two, and one of the things you need to remember after you split it into two is that you're going to make this the positive and negative of itself. Therefore, when you switch the symbol, you have to switch, or when you switch the sign, you have to switch the symbol. Solve it, and then graph it, and then come up with an answer like this at the bottom with the domain and range notation.